So, hello everyone. Myself, Raj Gautam. I'm doing my sophomore year in BTech Material Science. Anybody from Material Science here? So nobody. Even I am the only one in the club from Material Science department. So let's start. Before starting the workshop, I will start the workshop with a question. Okay, how many of you attended the orientation here? Okay, quite a lot of people. In the previous orientation, I just mentioned about. I just mentioned the term simulation. Do you know what is a simulation? Yeah, it's correct. Okay. Basically, yeah, as you can see here, simulation is a model that we just test the model in a virtual environment without bringing the product, without bringing the physical prototype. I would like to mention the phrase without bringing the physical prototype. Do you know why I'm just mentioning this? Because last time I just simply told this is simulation. But here I'm mentioning the phrase without bringing a physical product. Actually, this answers the question, why do we need simulation? Simulation is one of the important process when we are just going on through robotics. We need simulation because we can't just go and build directly the random models. It just takes a lot of time, lot of products, and it just increase the budget of our model. So simulation actually helps us, and basically the simulators actually helps us to reduce the development cost and time of a model we are building. So just okay, if I pause it between, kindly apologize me because I have problem connected in between. So I'll just continue. We don't have ample amount of resources in our club or just in any places we don't have ample amount of resources to waste the to reduce the wastage of the resources, we need simulators. So, what are we actually doing in simulation? So, I said, what is simulation? Why are we using simulation? What do we actually do in simulation? Anybody? Uh, Yeah, basically, what we do in simulation is that we bring the physical model and we check the physical properties and components of that model. So, about the physical properties, we just the physical properties is defined by links and joints. Are you hearing this term for the first time or have you heard it before? Huh? I will explain it later. Yeah. Have anybody learned of this? If you are a biology student in 11th and 12th, you might have known it. Unfortunately, I have done biology in 11th and 12th. Of no course. Okay. Uh, in terms of biology, I'm just explaining it directly. So just look on to your hand. In your hand, just wave your hand. In our hand, you can see we have bones. This bones represents the links, whereas the meeting point of bones is called as joint. Just like how, just like how I explained in hands, I just extend it to the term of robotics. Basically, links are strong support structure which builds the overall model, while the joints connects the two or more adjacent links. Apart from these physical properties, I also mentioned some components. Yeah, what's components? Basically, it's the sensors, actuators, grippers, which we use to build a model. You might have heard these terms many times, but do you people know actually what a sensor do or what an actuator do? Anybody? Each sensor is built different, so it just develops and collects the data from the environment and sends to the MCU. From the MCU sends it to the actuator, the actuator and converts it into the physical actions. I think Villa is quite often Villa because he's been the only person answering since the orientation. Okay, I'll put. Okay, I'll put this in a simpler terms. Sensors, it takes the input from the physical world and converts it into a digital signal, while actuators take the digital signal and gives the output to the physical world. For example, for sensors, we can give us temperature sensor, which is measures the temperature. While for actuators, we can give electric motors where it connects the electrical in an electrical circuit when electricity is passed the motor drives. It's just an output. That's what actuators do. Okay, we will go on about the simulation part later. Now, I would like to ask a question. This I asked it previously, but I would like to ask it again. Did you watch the tutorial you just sent in the WhatsApp group? And how many of you did download the Coppeliasim application? Okay, I said I have no issues. 1, 2, 3. Just write the hands. What's the issue with that? Nobody's going to help you. Okay, fine. I'll just explain it once again. How to download the Coppeliasim. So open any browser, search for Coppeliasim, download. Wait a minute. Open any browser, just search for Coppeliasim, download. You'll see a website called as Coppeliasim Robotics. Click on that. Just scroll down. You'll just see the download part. In that, just download the Edu version, which is suitable for your computer or PC. And then click download, run the exe file, and just set it up. This is the process. And since most of you have done it, I'm just going to skip this part and just going to further proceed on next part. So everybody open the application. You'll see the basic opening interface, actually. Till now, any questions? Now I feel the problems faced by the professors. Okay, fine. Here I will just explain you the basics. Wait, I'll just open the application first. Yeah. I'll just explain you the basics, how to just use Coppeliasim application, and later parts will be proceeded by my mates here. Yeah, I'll just continue. I'll just start off with this thing. Actually, this is called as floor. As it suggests, it's the ground. It's the ground where we build all our simulation process, simulator models. And this place where the floor being located, this is called as scene. Just to give you an analogy, if you open a Chrome, the search bar is called as floor, where we just search things which we use to search things, and the tabs which we use to search different things is similar to the scene here. And this tab here, this is known as scene hierarchy. Basically, scene hierarchy shows us the arrangement of models in a hierarchical way. This will be later explained by my friend Dilshan, but I'll just give you a brief. And near towards left of it, we have model browser. Here we have pre-built models which we can directly import to our flow. I'll just import any model later. Yeah.
we can just directly import it from here. So far, any doubts? Okay, then I'll go ahead. I'll just explain you this ribbon part. Actually, this ribbon contains around 14 to 15 functions which we can use. First one is camera pan. If you select camera pan, you can just move the floor vertical. You can just use it for translation of the floor. The second option is camera rotate. This just changes the orientation of the camera to look onto the object or the world. We just say this as a world. We can the total, including the object and floor, we totally consider it as a world. Then third one is camera shift. This basically zooms in and zoom out the object. And fourth one is again the camera view size. This also zoom in and zoom out. So what do you think is the difference between camera view and camera shift? Camera shift, yeah. Anybody? You can use it in your PC and can you tell me what's the difference? Camera shift and camera view size. What? Yeah. So just a second, my kid's being passed.
Camera shift seems to be actually physically move the camera and not the world. And camera view size seems to be zooming out.
Okay. Any other answers? Yeah, here.
From our perspective, both look very similar, but if we look at the camera, in one of the case, the lens is zooming into the thing, in the other case, the camera itself is moving forwards towards it.
Yeah, it's kind of similar, but it's exactly what you're saying is okay. But what does camera view size has a specialty is that it gives us the precision, more precision towards the object which we are zooming. That's the difference between camera shift and camera view size. Then later one is fit to view. As the name suggests, you just fit the view accordingly. Just zoom in the total environment. If you add just another one object such as I'm just showing this, it'll again if you give fit to view, it just fit us to the object which we have been selected. If you just deselect the object, it just fits totally. Yeah. Next one is click selection. It's if you turn it on, you can just select and deselect objects. If you turn it off, you can't select the objects actually. Then later, this option is called object shift. This is used to shift the object, shift the selected object actually. Basically, on any directions. If you want to select the preferred axis for that objects to be shifted. Next one is object rotate. Object rotate usually helps us to rotate the object in the axis of the parent axis, that is the axis of the object or the axis of the flow. Now it's rotating about the z axis of the object. If you select y axis or x axis, it rotates accordingly. Later, these two parts are not that important right now. Then undo and redo options. And here is the main part. Actually, this button is start simulation, pause simulation, and stop simulation. Start simulations just starts your simulation. Okay. Then this pauses your simulation and stop simulation just stops your simulation and return back. If you feel that the simulation is very fast, you can use this slow down simulation to just slow down the process. And if you feel it's very slow, you can just use the speed up simulation to speed up the process. And finally, I'll just say about this. Yeah, this is page selector. Actually, we can view in different angle. Which angle do you, if you want to see in a different angle, you can just select the particular page and see it. I think that's from my side. Any doubts for you guys, from you guys? Okay, if there is no doubts, I will hand over it to Dilshan. Thank you.
Hello everyone, I'm audible. I hope everyone has understood what Raj Gautam has taught. Now I will explain you about some basics of Coppeliasim. First open this slide. Right. So I will explain you about the scene hierarchy. In the scene hierarchy, it represents all objects, models, and components like tree. Okay. It defines all the objects are connected, grouped, and affected by each other. You can see there, this is scene hierarchy of a bot, and everything placed there is objects. Okay. What now? Parent-child relationship. So anything at the top in the scene hierarchy is parent, and objects inside it is child of the parent. For example, child follows its parents. For example, your upper arm is the parent of your lower arm, and if you move your arm, will move with it. Okay. We can do various things from this scene hierarchy, like we can drag and drop things and copy paste, just like we do in File Explorer. Okay. Any doubt? No? Now objects and joints. In Coppeliasim, everything that appears in the scene hierarchy or everything is any element is an object. Okay, and joints connects two objects between them. Okay, can you give an example of a joint? Can anyone? Elbow. You can say elbow or any ball joint. This type of joints. Okay. Now, objects and joints have various properties like physical properties and dynamic properties. Okay, I will explain these things in Coppeliasim. So let's open the Coppeliasim. I hope everyone has installed Coppeliasim by now. I am opening a new scene. For that, go on the menu bar and click on File and click on New Scene. Okay. In this scene window, I am going to create an object. For that, you have to right click on the scene and then choose Add option. And in the Add option, you will see various things. These all are objects. I'm going to select primitive. I'm going to select a primitive shape and a cuboid. You have to define its size. I'm defining a 0.1 meter, 0.1 meter, and 0.3 for now. So this is the object created in the scene. Okay. Now we can do various things with this object, like we can translate it. To translate it, click on the icon there, which has 4 outward arrows. And you have to keep selected the object. Now you can move this object along the preferred axis that you have selected. Like you can move it along the X, Y, or you can deselect one of the axes. Now it will move only in X axis. Okay. We can also do rotation of this object similar to the way we have done translation. For that, you have to select the rotation option, which is just adjacent to the translation button. Okay, and it will rotate along the preferred axis that is selected right now, like it is rotating about the Z axis. You can also provide some rotation angle by going to the rotation button and providing angles, like I am providing, let's say 90° along X axis. And when you click rotate, then object will rotate along the X axis by 90°.
ओके सो सबको समझ आ गया ऑब्जेक्ट्स को रोटेट कैसे करते हैं, मूव कैसे करते हैं. ओके नाउ एक स्मॉल चैलेंज. अभी हमने क्यूबॉइड ऐड करा है. I want you guys to try and add a cylinder and try to rotate it 90 degree about any of one of these axes. See if you can do it. If you have any doubts, let us know, just so that you know what to do. This is the basics. This is called modeling. If किस का यहाँ पे CAD वाला कोर्स हो चुका है, so कुछ सिमिलर लग रहा है. आई गेस ये देखा होगा, थोड़ा ट्रॉमा होगा इसका. इसमें इतना ट्रॉमेटिक नहीं है ये, बट थोड़ा हो सकता है. So just try out once, and if you face any doubts, let us know.
I'm explaining a process of adding an object again. For that, you have to right click on the scene and then go to add option. And from there, you have to go to primitive shape option and choose your desired shape. Okay, I am again choosing cuboid. I want to make a rod shape and provide dimension according to your desired. So I have added another object, which is a rod. Now, now you can make this make the rod child of the bigger cuboid. For that, from the scene hierarchy, drag the rod and make sure to drop it on the cuboid. When the cuboid is highlighted, then drop it. Otherwise, it will not become the child. Okay. Now, as you know, child will follow its parents. So if I translate parent, you can see I have selected parent from the scene hierarchy. I have selected bigger cuboid, which is the parent of the rod. And if I translate it now from by clicking on the translate button from the menu bar, then child and parent both will translate along the x and y axis according to my mouse rotation. But if I move, if I rotate, translate child, then it will only translate. Okay. Now I will explain you about some object properties. Any doubt till now? So to open the object properties, go to any object and click on the icon of the object. Like I am clicking on the cube shape, double click on the cube shape, and then object properties will open. From there, you can change various properties like physical properties like color or geometry. So just select a color to change the color of the object. Then go to ambient component, and then you can select RGB values to change the color of the object like this. Is anyone able to do this? Everyone able to do this? Just double click on the object icon. Blue color, it will be of the blue color cube shape. Just double click on it. I'm showing it again. Just double click on it. Then window will open, object properties window. From there, you can select color and various things. Okay. Other property that you can select is geometry. From the geometry, it is in below the here, and from there. Okay.
इतना समझ आ गया तो कलर कैसे देख सकते हैं सब लोग एक बार ट्राई करो.
Are you able to open the object properties dialog box? There you will see an object color button. You can see it.
Okay.
Okay.
So we will go to the scene hierarchy. You see there's two cuboids right now.
I have removed the parent-child relationship. To make a rod which is cuboid 1, the child of cuboid 0, you have to drag the cuboid 1 and drop it on the cuboid 0. When cuboid 0 is highlighted, then drop it on it. Okay, then bigger cuboid is the parent and rod is the child. Are you able to do?
Okay, so cylinder वाला जो मैंने बोला था वो किससे होता है वो करने की जरूरत नहीं है. नहीं हुआ मैंने हाथ पाया. Okay. आप लोग जिसको एक बार एंड अनदर विल कम वेरी We'll stop them for a second and we'll wait till the whole without spraying it, then we'll move on.
Just call any senior if you are not able to do. Now, if you have understand object properties, now let me explain about the dynamic object properties. Let me explain geometry again. Select any object and double click on its icon. I have selected the rod and double clicked on the cube shaped icon. Then you can go on the geometry button and click on it. And if you want to increase the size of the rod proportionally, then then check the keep proportion. Otherwise, uncheck it. I am unchecking it, and then increase size in any direction. Let's say I will decrease size in the direction by point. I'm making it 0.3. So you can change the geometry in this way. Are you able to do this?
Okay, so check this. Object stack करना है सबको. Is one. Okay. पहले change करना है. Object properties dialog box खोलना है. Geometry कैसे change करना है? Geometry change करने का मतलब क्या होता है समझ आ गया? Exactly. ठीक है. Basically किसी को भी आगे भी आउट से जब change करा के भी देख Okay, so 1 second. Object add करना आ गया, object properties dialog box खोलना आ गया, पहला geometry change करना आ गया. Any doubts? Can we move on? और तेज बोलो, जब तक ऐसी चीजें आगे ही बढ़ो. Let's move on.
So अब चलो अब हम लोग आगे क्यूबॉइड की मतलब डायनेमिक प्रॉपर्टी समझते हैं. So to change the dynamic properties, नीचे एक बटन है डायनेमिक प्रॉपर्टी, उस पर क्लिक करना है. अभी मैंने ये सिलेक्ट कर रखा है बड़ा क्यूबॉइड. तुम लोग भी सिलेक्ट कर लो बाय क्लिकिंग ऑन दी सीन हायरार्की से उस पर क्लिक करके सिलेक्ट कर लो. एंड देन डायनेमिक प्रॉपर्टीज डायलॉग पे क्लिक करके ये वाली डायलॉग बॉक्स ओपन कर लो. तो सबसे टॉप पे देयर इज अ चेक बॉक्स बॉडी इज रिस्पॉन्डेबल. इसका मीनिंग होता है कि बॉडी जो है हमारे सीन में कोलाइडेबल होगा, डिटेक्टेबल होगा. अगर ये अनचेक कर दोगे तो बॉडी कोलाइडेबल नहीं होगा. लाइक अभी मैं अगर सिमुलेशन रन करूँ तो कुछ नहीं हो रहा, ठीक है. लेकिन अगर मैं अभी अनचेक कर दे रहा हूँ बॉडी इज रिस्पॉन्डेबल को और देन सिमुलेशन रन कर रहा हूँ तो अभी जो मैंने सिलेक्टेड ऑब्जेक्ट था वो कोलाइडेबल नहीं है और बस फ्लोर से नीचे गिर गया, ठीक है. तो ये समझ आ रहा है सबको. एंड सिमिलरली बॉडी इज डायनेमिक, देयर इज अ बटन, वहां से हम लोग इसकी मास को डिफाइन कर सकते हैं एंड बाकी डायनेमिक प्रॉपर्टीज को डिफाइन कर सकते हैं, ठीक है. नाउ अब हम लोग एक नया कोई ऑब्जेक्ट क्रिएट करते हैं. लाइक मैं एक जॉइंट क्रिएट करके दिखाता हूँ एंड देन आई विल टेल यू अबाउट देयर प्रॉपर्टीज. सो टू ऐड अ जॉइंट,
डायनामिक प्रॉपर्टीज सबको समझ आ गया. डायनामिक प्रॉपर्टीज क्यों चाहिए होती है मतलब सबको. एनी डाउट इन दैट? केएमएल वाला क्वेश्चन फिक्स है अभी. उससे कवर करना था डायनामिक प्रॉपर्टीज में मास इनर्शिया मैट्रिक्स.
या
सबको पता है सब कुछ क्या होता है. हाँ. ओके. डायनामिक प्रॉपर्टीज है टॉपिक पर दोबारा फिर एक्सप्लेन करेंगे.
सो पहले ऑब्जेक्ट वाली प्रॉपर्टीज खोलो डबल क्लिक करके, देन क्लिक ऑन द डायनेमिक प्रॉपर्टीज डायलॉग बॉक्स. सो बॉडी इज डायनेमिक चेक बॉक्स आ जाएगा, वहां से तुम चेंज कर सकते हो जैसे मास या फिर इनर्शिया मैट्रिक्स और यू कैन डिफाइन सेंटर ऑफ मास. ये काम आते हैं. ये मीन्स अगर ये नहीं लगाओगे तो मीन्स तुम ऑब्जेक्ट को काइनेमेटिक चीजें दे सकते हो, लाइक इसको मोशन दे सकते हो, ये चीजें दे सकते हो. लेकिन जब बॉडी डायनेमिक है तो ये इसको ये फोर्स समझेगा, ये टॉर्क समझेगा कि कैसे कितना झेल सकता है, कैसे झेल सकता है, ये सारी चीजें, ठीक है. मतलब अभी ज्वाइंट वाइंट लगा के इसमें कुछ करनी होती है तो फिर तुम इसको दिखा सकते हो कि कितनी फोर्स झेल सकता है, नहीं झेल सकता, ठीक है. तो अभी के लिए बॉडी डायनेमिक पे टिक किए रहो. समझ आ गया. APL में
Yes,
पढ़ोगे।
inertia matrix about the inertia matrix. I think JEE and clearly
हाँ.
there's a course here applied mechanics course.
Applied mechanics.
Inertia matrix basically rotation define करता है in three axes. So उसका exact कैसे निकलता है and that's the reason little out of scope for this workshop. But just learn about inertia matrix and you will get to know what it is. Okay. It's basically a dynamic property. So dynamic property means एक body का force या torque उस पर अगर लगता है तो वो body कैसे react करेगी. So that's what you define. So जैसे force के लिए mass होता है S equals to M. Inertia matrix is the same for the torque and rotation. If you use torque's equation, it is E equals to IR. So I is the actually the rotation, inertia matrix. Yeah, I am sorry. I said that.
तो आगे बढ़ते हैं अब. तो अब मैं एक जॉइंट ऐड करने जा रहा हूँ. उसके लिए यू हैव टू राइट क्लिक ऑन द सीन, देन गो टू ऐड ऑप्शन, और वहां से प्रिमिटिव शेप के नीचे जॉइंट ऑप्शन है, उस पे जाके देयर आर 3 टाइप्स ऑफ जॉइंट. तो अभी के लिए आई एम गोइंग टू सेलेक्ट रिवॉल्यूट जॉइंट. क्या पता है सबको रिवॉल्यूट जॉइंट क्या होता है? बेसिकली ये रिवॉल्यूशन प्रोवाइड करता है दो ऑब्जेक्ट्स के बीच में. ठीक है. अब मैं इसकी प्रॉपर्टीज चेंज करके दिखाता हूँ. लाइक इसकी प्रॉपर्टीज ओपन करने के लिए सेम सिमिलर वे में यहाँ पे आइकन पे जानी है एंड यू हैव टू डबल क्लिक ऑन इट. ओके. तो डायलॉग बॉक्स ओपन होगी. ऊपर में चीजें कॉन्फ़िगरेशन इसकी डिफाइंड है, इसकी मोड डिफाइंड है. लाइक इस जॉइंट को अभी हमने डायनेमिक मोड दे रखा है. लाइक ये टॉर्क, इसको इसमें टॉर्क डिफाइन कर सकते हैं. ये चीजें अदर मोड्स भी होती है. लाइक हमें डायनेमिक चीजें से फर्क नहीं पड़ रहा है तो हम काइनेमेटिक मोड कर सकते हैं. ये सारी चीजें हैं. एंड वी कैन ऑल्सो चेंज इट्स फिजिकल अपीयरेंस. फिजिकल अपीयरेंस इसके अदर चीजों पे डिपेंड नहीं करेगी. मींस ये सिर्फ हमें विजुअल रिप्रेजेंटेशन के लिए है. लाइक मैं इसकी लेंथ को चेंज कर सकता हूँ. लाइक मैंने 0.15 से पॉइंट ये किया और इसके डायमीटर को लाइक चेंज कर दो. ये सब कर पा रहे हो तुम लोग? लाइक अभी तो डायमीटर बढ़ गया, मैं और कम कर देता हूँ. ये हो पा रहा है? ज्वाइंट प्रॉपर्टीज डायलॉग बॉक्स खुल पा रही है और विजुअल प्रॉपर्टीज चेंज कर पा रहे हो तुम लोग? यू कैन ऑल्सो चेंज कलर. यहाँ पे कलर है साइड में, सिमिलर वे में ऑब्जेक्ट प्रॉपर्टीज जैसे करते थे वैसे ही. यू कैन गो टू एम्बियंट, डिफ्यूज कंपोनेंट और तुम कलर चेंज कर सकते हो. ये सब बेसिक हमारे विजुअल के लिए, ये फिजिक्स में काम नहीं आता. एंड यू कैन ऑल्सो डिफाइन इट्स डायनेमिक प्रॉपर्टीज. वो मैं अभी थोड़ी देर में करके दिखाऊंगा. फर्स्ट वी विल प्लेस दिस रिवॉल्यूट जॉइंट ऑन द टॉप ऑफ दिस ऑब्जेक्ट. ठीक है. उसके लिए तुम्हें क्या करना है, इस रिवॉल्यूट जॉइंट को अभी इसको चाइल्ड बना के दिखाओ. इस रिवॉल्यूट जॉइंट को चाइल्ड बना के दिखाओ ये अपर क्यूबॉइड का. उसके लिए क्या करेंगे हम लोग, बताओ?
तो पेरेंट क्यूबॉइड है तो मैं वो जॉइंट को उसका चाइल्ड बनाना है. एंड फिर जो एक और चाइल्ड क्यूबॉइड है उसको जॉइंट का चाइल्ड. ओके. प्रायर नोशंस दैट विल शो हाउ टू डू इट इफ एनीवन हैज एनी डाउट्स.
एंड इसको ट्रांसलेट भी कर लो. ये रिवॉल्यूट जॉइंट को इस यहाँ तक ट्रांसलेट भी कर लो अगर कर सकते हो.
Okay, everyone good with this? Has anyone done this or like facing any issues? Guys? Comments? Okay, take more time. Okay, any success? Has anyone been able to do it? On the top of the skateboard. Yeah. Anyone able to do it? Yeah, very good. Okay, nice. Okay, 4 5 people. Okay, for the rest of us,
I will explain you if
okay.
I am explaining how to do this. First, I am going to place this revolute joint on the top of the cuboid. For that, select revolute joint from the scene hierarchy, and then go to translate button. And from there, you can move it in the preferred axis, like I am moving it in the XY. And then I will move it only along its Z axis to move it upward. And I will place it in the center of this. Okay, I think it is fine for now. Or we can also, I think this is the center. Okay. Now you also have to make this revolute joint the child of the upper cuboid. For that, drag the revolute joint from the scene hierarchy and drop it on the upper cuboid. Are you able to do this? That is the child, therefore it has same name. You can also change the name by double clicking on it, and you can name whatever you want. Now select the rod and drag it and drop it on the revolute joint to make the rod the child of revolute joint. And you also have to translate this rod at the top of this joint. For that, go to translation button and select Z axis only. Okay. Now X and Y. And then again select only Z axis to move it upward. So now everything is fine, I think. Wait. Okay. So this way you can place everything like this. And now I'm going to run the simulation. I will explain you about the joint properties now, and then you will be able to run the simulation. Just double click on the revolute joint button and tell me, are you able to do these things?
Is everyone done this? Everyone with the cube objects and going.
That one, we invent the
It doesn't really matter. The best to make a child of the joint, it will just move in the way it is. The thing will be in the joint. It's just a visual way. It doesn't physically always exist. Everyone done with this? Please good, please good. Louder, louder. Should we move forward? Okay.
डाउट बता दो कहाँ फंस रहे हो, सीनियर से पूछ लो साइड में जो
You
भी.
can just raise your hand in your gap because where will be.
लाइक ये हायरार्की बना लो, फिर इजीली हो जाएगी. यू हैव टू मेक दिस हायरार्की क्यूबॉइड, उसके अंदर रिवॉल्यूट ज्वाइंट एंड देन उसके अंदर रॉड. बाय जस्ट ड्रैगिंग एंड ड्रॉपिंग इट बन जाएगी ये. और ये हो जाए तो बता दो.
Second, is everyone done now? Should be speak out if you want your voice in that, speak out. Done? Okay, done going once, going twice, going three next. Okay, wait, okay. Okay, so I think that's simple now. Let's
Yeah.
move on to the properties.
Now अभी बस now we have to just provide revolute joint to properties provide करनी है. For now you can see अगर मैं revolution अगर मैं simulation start करूँ तो nothing will happen because I have not given joint any properties. So stop simulation for now. Or again open the joint properties window by double clicking on the joint icon. खुल रहा है ये सबका. एंड देन डायनेमिक प्रॉपर्टीज पे जानी है इस बार, क्योंकि हम फिजिकल प्रॉपर्टीज देख लिया हमने, अब डायनेमिक प्रॉपर्टीज चेंज करते हैं जॉइंट की. सो क्लिक ऑन द डायनेमिक प्रॉपर्टीज डायलॉग and then there you will see control mode. Currently it is free, that's why अभी simulation run करने पे कुछ नहीं हुआ था. Now you have various options like force, velocity, position. For now I am explaining you about position. So if you select position, तुम्हें target angle provide करनी है. Like if you provide it 90 degree and run the simulation, then the joint will move 90 degree from its current position. Okay, again run करके देख सकते हो ये हो रहा है. अगर ये बन गई है तो सही से हो जाएगा, इफ नॉट देन आई थिंक यू हैव नॉट मेड हायरार्कीज क्लियर, दैट्स व्हाई इट इज फॉलिंग डाउन.
Like just everyone you're able to your inland body about 90 degrees on the axis. If you have any other statements.
हाँ तो after making hierarchy and after making hierarchy clear and this representation, you have to double click on the revolute joint icon and इससे क्या होगी, joint properties खुल जाएगी. ठीक है, ये कर पा रहे हो, डबल क्लिक करो ज्वाइंट की आइकन पे, यहाँ जो दिख रही है मोटर साइज की, मोटर शेप की, उस पर डबल क्लिक करनी है. देन यू हैव टू गो टू डायनेमिक प्रॉपर्टीज, सबसे नीचे में ऑप्शन है डायनेमिक प्रॉपर्टीज डायलॉग, उस पे जाओ. टॉप में तुम्हें दिखेगी कंट्रोल मोड, वहां से फ्री होगी अभी, उसको फ्री को चेंज करके पोजीशन कर लो, तो तुम ज्वाइंट को कंट्रोल कर सकते हो बाय प्रोवाइडिंग इट पोजीशन. आर यू एबल टू डू दिस? लाइक 90 डिग्री के अलावा कुछ और भी देके देख लो, 180, so it will move 180 from its current position. If you are not able to make the hierarchy, मैं फिर से एक्सप्लेन करता हूँ. लाइक सबसे पहले सारी ऑब्जेक्ट्स को मैंने रिमूव कर दिया. नाउ एवरीवन इज नॉट एवरीवन इज पेरेंट, यू कैन से. तो फर्स्ट आई विल ड्रैग रिवॉल्यूट जॉइंट एंड ड्रॉप इट व्हेन क्यूब 0 इज हाईलाइटेड बाय येलो कलर. ओके, एंड देन रॉड को सिलेक्ट करनी है एंड यू हैव टू ड्रॉप इट ऑन द रिवॉल्यूट जॉइंट. व्हेन रिवॉल्यूट जॉइंट इज हाईलाइटेड तब ड्रॉप करनी है. सो यू हैव टू मेक दिस हायरार्की. अगर ये नहीं बन रही है तो नहीं होगी, बिकॉज इसी के बाद वी विल प्रोवाइड द जॉइंट प्रॉपर्टी, जॉइंट डायनेमिक प्रॉपर्टी, जिससे रोटेशन होगी. सीन हायरार्की बनाने के बाद डबल क्लिक करो, यू हैव टू डबल क्लिक ऑन द जॉइंट एंड एट द बॉटम चूज डायनेमिक प्रॉपर्टीज डायलॉग. वहां से यू हैव टू चेंज द कंट्रोल मोड फ्रॉम फ्री टू पोजीशन. यही वाला You can also change control mode from position to velocity, and you can provide it target velocity like 90 degree per second. And then if you run the simulation, then this will move with a 90 degree per second rotation. rotation, you have to double click on the joint and then go to dynamic joint properties. Okay, and यहाँ से control mode को velocity select करो and provide it a velocity like 90 degree anything. बस इतनी करनी है. अगर किसी ने कर लिया है तो पेरेंट को 90 डिग्री रोटेट करके देखो and then run the simulation and then see what will happen. Like you can see, I am running the simulation. These things will happen. Like it is physics simulator, तो इसके मास वास के हिसाब से ऐसा ही होगा, यही चीज है. नहीं, ये खुद हो रहा है. रन सिमुलेशन क्लिक करने पे अगर बन जाने के बाद यू हैव टू रोटेट द 90 डिग्री पेरेंट को एंड देन रन द सिमुलेशन. ये अपने आप होगा ऐसा कुछ. एंड इसी बेसिक्स पे रोबोट्स वर्क करती है. यू हैव टू make a joint and join two objects, and this is the basic you can say it's basic building block using which we build any robot, any hexabot or anything. We can simulate it in this environment. This now I think अगर आप नहीं कर पा रहे हो तो you should try it at home. I have done my part and I am handing over handing over to Shreyans, which will tell you about robotic arm, how to simulate a robotic arm in this environment.
I think everyone has an association for yes. Okay, so you will be the workshop.
ऐसा हो सकता है कि जो पीपीटी आपके पास है वो इस पीसी में डाल सकते हैं नीचे।
ओके, कैसे ड्राइव मिलेगी तो उस पे पीपीटी रहेगी।
नहीं जब जाएंगे तब डालते हैं ये तो
पीपीटी
उसमें बाद दे दो।
उसका कनेक्शन नहीं सर, कनेक्शन नहीं सर।
आपके पास कोई वायर है कुछ किसी के थ्रू डाल सकते हैं।
आई थिंक ये लॉक है, इसको सेव करना सिखा दे बस, या मैं सिखा देता हूँ। वन मोर थिंग, इफ यू वांट टू सेव, अगर किसी ने कर लिया है तो यू कैन सेव दिस सीन बाय क्लिकिंग द फाइल बटन एंड सेव सीन। यहाँ से सेव सीन करके यू हैव टू सेलेक्ट योर फोल्डर, डिजायर्ड फोल्डर, और वहाँ पे नेम दे के सेव कर लो, लाइक बॉट एनीथिंग, और फाइल से ही जाके यू कैन ओपन न्यू सीन। ठीक है, सो माय पार्ट इज ओवर, श्रेयांश विल टेक ओवर एंड एक्सप्लेन यू अबाउट रोबोटिक आर्म।
Hi guys, so I'm Shreyans. I will be explaining you about robotic arm, its structure, and basically how it is designed. So first of all, I would like to request you to scan this QR code and install all the files uploaded in the Google Drive link. The Google Drive link has also been shared in the WhatsApp group. You can download it from that as well. Download all the files and keep it saved, please. Scan this QR code to download there will be a drive link provided with the QR. So scan this and download all the files in that folder. Has everyone scanned the QR? Okay, so the drive link has been shared in the WhatsApp group. You can download it from that as well. We will move on to the structure of the robotic arm. So before starting with that, you have been provided a SARM.TTT file with the drive link. You can just double tap it to open it, or you can go over to File and click on Open Scene and select SARM.TTT.
Okay, guys, we need 20 minutes. We have shared the link on your WhatsApp groups, and we also shared the file. Let's once again. There is a drive link. You have to download those files and open sample capability. For that, you can either just double click that or go to the open scene command and file, and you can just open download capability of that. If it takes any, it's in there.
Okay, so has everyone downloaded the folder? Okay, so there is a SARM.TTT file. Just open that scene within the Coppeliasim. You can double tap it or go over to the file and open scene and select that scene. So since the scene is loaded, we can just move over to the structure of this robotic arm. Okay, it is a 5 degree of freedom serial manipulator. In short, we call it a SARM. Serial by definition means that the joints are connected in a chain, starting from this base link and moving over to this links one after the another in a chain sort of manner. So you can play with within the Coppeliasim environment and see the hierarchy as well. Okay, so this is the base link. To it, we have a link 1 connected, and over it, the top of it, we have a link 2, then link 3, link 4, link 5, and link 6. So they are basically connected as in a parent-child hierarchy, one after another, and hence a serial manipulator. For the degree of freedom part, by degree of freedom, we mean the number of actuations. That is basically the number of motors or movement providing robotic sensor. So we have a servo motor over here that is joint 2. We have a rotation as well. Below the model, there is a servo motor over here that provides it a rotation about the base link, and the middle arm is connected to that base link via another servo motor that is joint 1, joint 2, and above that lower arm we have another servo motor that is joint 3, and to that we have near the gripper another arm part that provides the rotation about the horizontal axis, that is joint 4, and for joint 5 we have a servo motor that basically provides the rotation of that gripper. And there is another interesting joint that we haven't introduced yet. It is a prismatic joint. This bi-revolute joint, as it is clear, it is like a hinge joint that basically provides an axis of rotation. For the prismatic joint, there is a slot through which some slot, through the slot, some rod or cuboid sort of material can slide, and that provides another degree of freedom. So for the jaws part of the gripper, we have been given 2 prismatic joints for each jaw. This is one of the jaws. Let me select this. The highlighted one is one of the jaws, and the other link is another jaw. So that's about the structure of the 5 degree of freedom serial manipulator. Do you have any doubts about the structure? Anyone? Okay. So the other type of joint basically provides it a motion, a sliding motion. So the object can basically slide over another object, not rotate. It can freely slide through that slot. Is it clear? Okay. We'd like to introduce the inverse kinematics and control. Forward kinematics is basically when we know all the joint angles, so we can directly, as we know that each joint value, we can directly compute the exact gripper position. We call it end effector in general terms. And for the inverse kinematics, the problem is exactly opposite of forward kinematics. That is, we have the required position where we want to move that end effector, and we need to compute that joint angles. There is certain importance to inverse kinematics more than forward kinematics, and that is because there are several possible solutions to inverse kinematics, but we have to select one that fits in all the required constraints, such as there can be collision constraints or workspace limitations as well. So for that, we have certain modules for solving inverse kinematics and mathematical equations. Now I would like Nitya sir to explain inverse kinematics.
There's two things on the board right now. Forward kinematics, inverse kinematics. You don't need to that. First is general question. Suppose we have a energy block. Suppose I have an energy. How many degrees of freedom do I have on the Okay, I have actually in your answer 6. Okay. What? Yes, three translation theory. Right, answer was actually 6. So every rigid body actually has 3 degrees of freedom. So translation theory. So now let's come to forward kinematics and inverse kinematics. Everyone knows what kinematics is. Something motion. Exactly. Kinematics is actually the study of motion without any auxiliary forces. You're just concerned with the position and the velocity of the object. Okay. So let's just take forward dynamics, inverse dynamics. Let me get it now. So I have an angle, right? I have a board here. and I go and then I go there. Okay. So what do you think? When I have to move my hair, what do I do? I move my then 90 way, I move my 50 days away. What do I do? Do I go back? No, right. I just move. I want to move my from this position to this position. So what do you think is? This is actually what inverse dynamics. I don't think that I have to move my arm 90. I think that I have to move from this location to this location. So when I'm thinking in the sense of positions, okay, in the real world, that is called inverse dynamics. I don't have to worry about what the angle has to be. I just have to worry about where I am. So that is called inverse dynamics. So do you guys want to maintain the relationship that I know after the relationship or not? Maybe like the process and geometry. Okay, let me show you my small presentation. So this is the ground. This is one thing. This is the second. And this is the regulatory, and this is the regulatory. Regulatory it allows rotation in one plane, in one axis. Right? So this is theta 1, and this is theta 2, and this is p. Suppose I have to control p now. Now what can I do? I know what these coordinates. What are these coordinates? This is relevant, this is relevant. Basically, I want to use the Google analysis. What are these coordinates? Okay, what answers. And one cos theta 1 and c1 plus c1 and plus L2 c1 plus 2. Right? Theta plus theta. For you to ask it out, this is theta 1. Right? I will do this. And for I can this on the mean and experiment and plus L2 s1 plus 2. Okay. So now what can I do? I can divide these P1, S1, S1, S2, C2, basically theta 1, theta 2. Right? If I can give theta 1, theta 2, then calculate X and Y. Yes? And calculate this is point of dynamics. Just this. You have to just put this in this equation. Now this just has 2 points, right? If you have like 6 joints, this will get a lot more irritating, which will come to by which is why we use coppeliasim. We don't have to actually manually calculate. That's how we can get confused. So, and if I give you X and Y, can I calculate theta 1 and theta 2? Yes? Can I calculate it? No. Why not? We can calculate similar, right? So I have this situation there. Because I was already to the okay. No worries. Okay. Then let me just give you C might be C, right? C would actually come up to be PDX squared plus CY squared minus L1 squared minus L2 squared over L1, L2, L2. Right? I'm going to give you this and I'm going to see what for you guys. I hope you will work it out. If you don't work it out, go with it. Fine. Now I give you understand what is orbital dynamics and what's dynamics. And now you understand why it is what is robotics. Right? Robotics is one of the main types of robots. This is actually very important. And this can actually also be used in mobile robotics. If you see a robot driving, you can actually somehow implement this on that as well. But I'm going to leave that for you guys to do. I can't tell anything, right? Okay, so this is what dynamics and motion dynamics. Now there is the implementation of this is what the dynamic using right now. So just so you know, Aditya will continue and they'll show you how you can implement forward dynamics for the that we showed you. Just any doubts? No?
Okay. Just a quick show of hands. How many people here are familiar with Python? Okay. I see many of you are not familiar with Python. So, are you familiar with any programming language at all? Right. There's no one here who has no experience in programming, right? Or is there anyone? Okay. So Lua. So Coppeliasim natively uses its own a different language than most applications. It's called Lua. It's basically a scripting language that works really well with applications that are written in C++, and it's mainly a copy paste based language, and it's used for scripting and robotics stuff. So I will quickly go to the scene over here. I want you all to click on the SARM, right click, go to add. From here, you can go to script, simulation script, non-threaded, and Lua. Is everyone here with me? Okay, so you can click that. So you can see it will create a blank script. It has a basic functions. So I have done the majority of the work for you. You can open in the drive link I have given. You can open the forward kinematics.ttt. I will wait for a few seconds for you to open that.
You have to just open cascade or triple delete from the folder.
Forward one.
Right now you are on SARM. Now you have to open cascade. Let's say you open SARM.
Okay, so if you open the script here, you can open the script by just double clicking on the icon. You can see there's a bit of code here. So let me first explain the code. Okay, so the first line is sim is requires sim. This is basically the initializer for a Lua script inside Coppeliasim. Okay, then we start by defining a function move to config. It basically takes the target configuration and it takes some limiters like maximum acceleration, velocity, jerk to basically initialize the platform. Now I will come to the main function. This is function syscall underscore thread. So as you can see, I start here by getting the handles for all 7 of my joints. So the way this works is basically you can see joint 1 in the object hierarchy, but inside the simulation inside Coppeliasim, they have different values for this part, right? So it will have a numeric value for this joint basically. So I will start by getting these values. So I take all 7 of these values and I store it in a list. Everyone is aware of lists, right? Okay. Then what I do is I basically define maximum parameters for velocity, acceleration, and jerk. So this is done basically so that you can see the arm move. If I don't define any maximum parameters, the arm will basically just teleport to the location I am saying it to go. Right? You will not see a motion. So I do that for all 7 joints. Then what I do is I have, you can see target pause 1, local target pause 1. Right. So it has 7 values, basically 7 positions. That is pi by 2, pi by 2, minus pi by 2, pi by 2, pi by 2, 0, 0. So these are the position of each joint that I want the arm to move. Right. I do this 3 different times and I basically end the script here. So if I go over to Coppeliasim and run this, you can see that the arm does a smooth movement and ends the simulation. Right, it goes to 3 positions, and that's it basically. So I want you all to take a minute or two to basically play around with this. You can, try putting velocity 0 and see what happens. You can put different target positions and see what happens.
And guys, if people can motivate, at the end of the workshop, we will an assignment, and for that assignment, you can actually define the virtual and a robot key. For people who don't know what a robot is, stick around, it's very information. We will tell you about that actually at the end of the workshop. And we'll also contribute to it when we're starting implementation, so to stick around.
So has everyone tried running the bot at least once? All right, so I will now hand over to Aditya. He will explain how you can not use Lua to run the arm.
Hello everyone, my name is Aditya. So what I'm gonna do, I'm gonna use Python to run this simulation. So let me show you something. So this is a GUI graphical interface using which I'm going to control the simulation. So as you can see, if I move the slider of joint 5, the joint 5 moves. And similarly, if I move the joint 3 slider, the joint 3 moves. Okay. So let's understand what the code is doing. To use this, in our Lua script, what we have basically done is implemented this code block. What this does is start a API server, which enables our Python code to communicate with it and control it. So this program, can you all open API.ttt from the downloaded folder? There you will have the simulation. Done. And apart from that, you also need to transfer a Python in Python files. You have to transfer according to your system to the Python files. And you can use that to run the simulation using the Python code. So let's understand the code. The Python code block consists of the libraries that we are using is sim, tkinter, and math. Is everyone familiar with math? A show of hand. Can anyone tell me the full form of API? No one? Yeah. Like the full form. Okay. So SIM is an API library which enables our Python code to communicate with our simulation. Tkinter is a GUI library which enables us to draw the slider window. And the APIs that Sim library provides is Simex start, Simex get object handle, Simex get position, Simex get vision, and Simex finish. So Simex start connects to this simulator, Simex get object handle, find object ID, Simex set position, moves the joint, Simex get vision, read camera data, and Simex finish closes the connection. Can anyone tell me which of these API call we would be not using? Yeah, we won't be using because we haven't implemented a camera sensor in it. So this is Simex finish. This basically what it does is cancels all previous connection with our simulation and starts a new connection with our simulation. Simex start. This one is your connection address, and this one is your connection port. From our Lua script, we have started an API server on this port. Wait for connection is true, meaning it won't continue until it is connected to the simulation. And after that, the input format of Simex start is connection address, connection port, wait for connection, reconnect on timeout, timeout in millisecond, and form thread cycle in millisecond. Form thread cycle in millisecond is basically the frequency at which data is being transferred between your Python code block and your simulation. Timeout in millisecond is basically how much time it would wait before connection is established. So moving on, we have created a Revolut handle list, and we are going to put all the connection object IDs in this list. This is done by the API call Simex get object handle. So every object like joint 1, joint 2, joint 3, joint 4, every one of them has a unique ID in our simulation. And this API call basically goes to our simulation, extract it, and gives us to give it to us. And the input format of this API call is client ID, which we basically have stored it in this variable using Simex start. Client ID and object name, meaning joint one. So if we will provide it in the form of SRAM joint I, which we will be using in a loop, as you can see for I in range 6 to 8, and there is operation mode. So there are basically three types of operation mode: blocking, which will wait until the result arrives. Like this, after the code won't be executed further until the simulation respond to us. Simex one shot, meaning you just give the input to the simulation and the code will move forward. It won't wait until the result arrives. And for continuous data streaming, there is op mode streaming. So we have stored Revolut handles ID in Revolut handle list, prismatic handle IDs in prismatic handle list using the loops. Now, this is the code block which basically draws the tkinter GUI. So we won't be diving much into tkinter, but I will explain the overall what it is happening. So the root, these code line, basically what it does, it draws a window and it keeps a frame in which we will put the sliders in. And then there is def create Revolut slider, the horizontal, vertical sliders which we were using to control the joints. These will be created by create Revolut slider function, and we will set the we will give the input to the simulation by using the API call Simex set joint position. The input format of this API call is client ID, joint handle, angle position, meaning the angle or position you want to set the joint in, and the operation mode we are using is one shot, meaning it won't wait to response to arrive. And after that, we create prism frame, which is the horizontal slider which we are using to control the gripper. So we are again using the Simex set joint position API call to move the slider, and thus via that we are moving the gripper. After that, the last line basically what it does is closes the connection once we close our program. After that, my friend will take over.
ये वाला कुछ पता नहीं
Okay. So guys, if you don't follow me, so uh, I will be explaining inverse kinematics, and ये सबसे कोई part है इस पूरे like Coppeliasim का, because we will be like simulating the arm to go from one point to the other side. ठीक है? तो ये सब explain करने के लिए आप लोगों को पहले आप हो चुके हैं. ठीक है क्या? So now सबको एक बार I hope like everyone will please report that inverse kinematics file on your Coppeliasim. I'm waiting for 1 minute. तो सबने रिपोर्ट कर लिया. इसने रिपोर्ट नहीं किया. ऐसे रिपोर्ट करेंगे. So as you can see, like the board is moving. First of all, there's a tip and there's a target, and what we are doing is we are moving tip to the target. So as you can see, like बहुत simple लग रहा होगा आपको कि ये कैसे हो गया यार, simple से ये चीजें हैं नहीं. But behind the scene काफी complex है script था, and I will explain that. First of all, like we done the simulation, the movement of the target to the tip. Okay, so and it is in straight line. So the script part. So this script has three main components. First is initialization. Second is the actuation part where the board moves from one point to the other. And third is like the cleaning part. As you know, the like the inverse kinematics solver takes a lot of RAM and CPU usage, so we need to clean it up after the simulation is completed. So as you can see here, what this three line does is get the quantum point that which at an interceptor. Interceptor means this farming area of the board, and where the target point where the interceptor should move to. And for this, we are using the inbuilt uh, inverse kinematics library called SIM. So the next important part is this the IK group and ban. We are so there is two type of motion, ban and ban. किसी को ban motion के बारे में पता है जी जब पढ़ा होगा and ban आप लोग को पता होगा जो ban motion होता है much more smoother. Similarly, the ban motion here is also much easier to simulate. So we will be using the tan motion simulator. And the third part where the actuation happens is this. This line what it does, it divides the entire motion from one point to the other point into 100 steps, and at each step the inverse kinematic calculation happens. But it is as you can see, like we get in inverse kinematics we get an angle to the coordinates. Like we are given the coordinates and we get the angles, and this happens like 100 times, and at each stage the ball moves by a small d like d factor or something. So it's just like till the entire simulation happens, and this part encapsulates that thing, and yeah, that's all. And then we have the cleanup part. We remove the unnecessary objects and waypoints. Yeah. So please keep it out regarding this. Is this it out? सबसे clear हो गया? सब समझ में गई? पहले मेरे को एक implement करना है पूरा ये करने की काम करती हूँ. तो
yeah, that's all for this. And I feel okay. So yeah. One more thing, guys. ये जो this system has a lot of parameters, and like you can see the target and the payment target, but just miss the trading because there's like multiple parameters. And I do not want to this like I used to play around with it, but you will see the behavior of the ball. Like if you in the filter part, the ball would somewhere in infinity and something like that happens. So yeah, that's you can play around with that tip. So yeah, we are doing that.
Okay, so for the Coppeliasim part, this was basically the extent of it. Now for a little bit of homework, but of course we have some benefits. It's not like you move on get it updated. We just have some incentives. So कहते हैं तो लोगों को उनकी benefits किसको पता है? Okay, not a lot of people. So then we introduce logo once again. For the people who were in the orientation, you must have definitely to very okay. So logo one is actually an international competition which investigated what's like of my height and we participated in them. The Indian nationals are actually conducted by Delhi itself. And last year, basically, a few months back into that, they were conducted here in Wales. So people from all over the country were there participating in the competition. And then the Indian national winners, which were the Indian winners. Okay. There was a college from Gujarat, so they actually went to Ulala, which is in Mongolia, and then they appeared in international teams as well. So we also participated in that, and in fact, we were the national champions in 2007, and we plan on participating in this year. So we are hoping to improve some pressures on that as well. So if you want to learn the most we can about robotics from single competitions, and make balls like me, like of my height, you can very much be involved in this stuff. So what you have to do is go to the PDF in your go to the PDF of the assignment in your about there's a video of the assignment. So you can actually see there's a assignment which I set up. So what you have to do is just what we have explained. You have to set up the scene model something. So the model is adequate. You can actually read it later. So yeah.
The model is a simple pendulum. You don't need to code. You just need to follow all the steps. And by following these steps, you can make a simple pendulum and then press on the play button. It will basically find a hold of gravity using the engine. It will move. So that is the assignment. And after that, once you have done that, you will have to use this Google Form link, and on this link you will have to upload the drive link in which you have uploaded the .triple file. And apart from what Sudhar has mentioned in this incentive, there is another intensive incentive, which is top 5 would get custom 3D printed or laser cut GUI. Okay, so the deadline is 16th October. So participate in numbers.